In the previous video lecture, we saw an example of the use of Kirchhoff's law, also known as the loop rule, to analyze complex circuits. Here is that same circuit from before, but instead of my guessing that the current to the 3-volt battery is from C to D downward, this time I'll guess, and how would I know ahead of time? I'll guess that it's upward. And as a consequence of this being the upward direction of X, when this X current approaches branch point B, part of it goes south, that's called current Y, and what's left after Y leaves this current X is X less Y, X minus Y. So now we've properly labeled our circuit with the current arrows, and were you to proceed as we did before by selecting 2 different loops and satisfying the condition for each loop that the sum of the sign voltages is 0, you solve those 2 equations, and this is what you get. Notice that I've obtained a current through the battery, a current through the 6 ohm resistor, and a current through the left side of this circuit. But notice further that 2 of the currents, X and X minus Y, are negative values. You wouldn't know what to do with those negative signs unless I tell you. I'll tell you now. Whenever any of your currents in various parts of the circuits turn out through your algebra to be negative numbers, this is what you do. You remove the negative sign, as shown here, and reverse the arrow. Remove the negative sign there and reverse the arrow. This current is good, is correct, because it turned out to be positive. If your currents ever turn out to be positive, they're good, they're correct. Negative currents, remove the negative sign and reverse the arrow. Watch me remove the negative sign from this and reverse the arrow. Watch me remove the negative sign from that current and reverse the arrow. Let's double check to make sure these currents seem to make sense. Approaching that branch point, formerly named branch point E, you have 2 currents. You've got the 0.82 ampere current passing through this resistor. It meets the 0.95 current that joins up with the 0.82, and the 2 together merge those 2 streams of current to provide a current that's a sum of the 2, the sum of 0.82 to there, 0.95 to the same point, join up to give the sum, which is 1.77. And so the numbers add up. And so this is what you would show to someone who wants to know what the currents are everywhere. Now you know what to do in the event that, should you be unlucky, it's a flip of the coin, 50-50, in your choice of the direction of a particular current, then the algebra at the end will tell you that you made an unlucky guess, but the fix is easy, and I've already described it. For the particular offending current that turns out to be negative, remove the negative sign and reverse the direction of the arrow for that current arrow. Kind of confusing, don't you think? These Kirchhoff law problems can be maddening. You have to be very careful, very patient. But who wants to be patient when we have so many problems to solve? Well, good night and good luck.